Hello everyone, good morning. In this lecture, I will discuss the position of carbon atoms in the austenite phase as well as ferrite phase. So, simply we know that the carbon atoms occupy the octahedral voids both in austenite as well as in ferrite. So, carbon atoms occupy octahedral voids. You must remember this, not in tetrahedral void. Now, there is a simple question here, and that is based on this particular information. The question is the number of carbon atom present in 100 unit cells of austenite phase of 0.1 weight% carbon are approximately. So basically first we have to understand what is percentage weight by weight, that is. So 0.1 weight% carbon, the simple meaning is if you take 100 gram of austenite, that is the gamma phase, then as we know austenite is made up of iron and carbon, so 0.1 gram will be carbon in it and rest 99.9 gram will be of iron. So this is basically the meaning of percentage weight by weight, that is out of 100 gram of austenite, 0.1 gram will be the carbon and 99.9 gram will be Fe. Now if you want to know the exact number of carbon atom or the moles of carbon present in 100 gram, then you have to divide with it gram atomic mass, that is 12. Similarly, for number of mole of iron atom, it will be 99.9 divided by 56, because gram atomic mass of iron is 56 gram per mole. Okay. Now, so for every this much moles of iron, this much mole of carbon will be present in the austenite phase, or you can say the number of iron atom will be just this number of mole multiplied with the Avogadro number. So if you want to calculate the number of iron atom in 100 gram austenite, so number of Fe atom should be 99.9 divided by 56 into Avogadro number. Avogadro number we know from the mole concept is 6.022 into 10 is to 23. Similarly, number of carbon atom should be 0.1 by 12 into Avogadro number. So again we can say that for this much number of iron atom, this much atom of carbon should be present in the austenite phase, because we have derived this with the help of the data given to us, that is the percentage weight of carbon in austenite phase. Now what we have to do, we have taken 100 unit cells of austenite. Okay, now austenite, we know that it has FCC crystal structure, and in FCC 1 unit cell contains 4 iron atoms, 4 Fe atoms, as well as 4 octahedral voids, that is 1 octahedral voids per iron atom. Now if you take 100 unit cell, then you will get 400 iron atoms as well as 400 octahedral voids. Okay, now we have to find the number of carbon atom present in 100 unit cells. So we know in 100 unit cell the number of carbon atom is 400. Okay, because one unit cell, that is the FCC, has the effective number of atom, that is 4 carbon atom in that. So, and also we know that if this is the amount of iron atom, then this will be the corresponding number of carbon atom. So from this we can apply the unitary method and we can find, for example, use this information. So we can easily write, so let me write here, 99.9 by 56 Na Fe atom is equivalent to 0.1 by 12 Na carbon atoms. Okay, so we can say 1 Fe atom will be equivalent to 0.1 by 12 Na, and this will go up, that is 56 divided by 99.9 Na carbon atom. So see, Na will be cancelled out. Now we have to find corresponding carbon atom, number of carbon atom in 100 unit cells. So in 100 unit cell we know that there are 400 Fe atoms. So if the number of Fe atom is 400, then the number of carbon atom will be simply 0.1 into 56 by 12 into 99.9 multiplied with 400. And if we solve it, we just get it. That is very simple here. 0.1 into 56 into 400, that is this much, divided by 12 divided by 99.9, and we will get, that is 1.868. okay, so that is 1.868 carbon atoms. So in the question it is given that the number of carbon atom are approximately, so in the option 1.8 is near to 2, so the most appropriate answer for this question is 2. So in 100 unit cell there are only 2 carbon atoms present, that is effective number of carbon atom is 2. So that's the end of this lecture. Kindly like the videos, subscribe it and share it, and give your comment, valuable comment in comment box. Thank you very much.